very warm good morning dear stars. How are you all? Students, I hope you have learned again about the Pythagoras theorem and its converse. So let us start with the exercise 6.5 which is based upon the Pythagoras theorem and its converse.
Dear stars, the very first question of your exercise 6.5 is: the sides of the triangle are given below. Determine which of them are right triangle. In case of a right triangle, write the length of the hypotenuse. Students, clearly hypotenuse is the largest side. To check whether these are the sides of a right angle or triangle or not, we will first check the property of Pythagoras theorem, that is hypotenuse square. Largest side square should be equal to the square of the sum of the other two sides. So very first case is 7 centimeter, 24 centimeter and 25 centimeter. Clearly the larger side is 25 centimeter. So 25 square is 625. Next we will find the square of 7 plus the square of 24. So 7 square 49, 24 square 576. On adding these two, we can easily check that both the values are equivalent to one another, that is LHS equal to RHS. Hence we can say that in first case, that is 7 centimeter, 24 centimeter and 25 centimeter are the sides of a right angled triangle and its hypotenuse length is 25 centimeter. Similarly students, the question number 2, here the triangle sides are given as 3 centimeter, 6 centimeter and 8 centimeter. The largest one is 8. So 8 square is 64 and here the square of 3 is 9 and the square of 6 is 36 and their addition is, on adding these two we are getting the sum on the LHS as 45, whereas our RHS is 64. Clearly these are not equal to one another, so it does not satisfy the Pythagoras theorem. So that means the sides 3 centimeter, 8 centimeter and 6 centimeter are not the sides of a right angled triangle. Likewise students, you can check the third part and fourth part by yourself. Now students, question number 2 is: PQR is a right angle triangle at P and M is a point on QR such as PM is perpendicular on QR. Then show that PM square is equal to QM into QR. Students, if you remember the Pythagoras theorem, PM square is equal to QM into MR is one of the intermediate result of the Pythagoras theorem. So let us understand how we are going to do this. So let us suppose that angle MPR is equal to S. So students, if MPR is X, then the angle MRP must be 90 minus X. Why? Because the whole angle is of 90 degree. So that means we can take the rest of the part as 90 minus X. Similarly, we will find the value of MPQ, which will come out to be 90 minus X, and MQP as X. So next is, in these two triangles, as we have already proved that these two angles are equal. Which angles? MPQ is equal to angle MRP. Similarly, angle PMQ is equal to angle RMP, that because both are 90 degree. So this implies by angle similarity both the smaller triangles are similar. So students, if the triangles are similar, their sides are in proportion, and the proportionality we will choose by ourselves what is to be proved. So we can write PM over QM is equal to MR over PM. When we do the cross multiplication, we will get the result as PM square is equal to QM into MR. So that's it for question number 2. Students, next question number 3 is: in the figure, ABD is a triangle right angled at A and AC is perpendicular to BD. Then we have to show that AB square equal to BC into DD, AC square is equal to BC into DC, and AD square is equal to BD into CD. Students, all these results are the intermediate results of the Pythagoras theorem. So first we will start with the first part, that is AB square is equal to BC into BD. So first we will check in which triangle AB, BC, C and BD are the parts of. Students, if you can see the figure clearly, here AB is a part of the greater triangle, that is the largest triangle. BC and BD, BC, BD are the part of the lower and the bigger triangle. So that means we will consider triangle ABC and the triangle ABD. How we are going to prove them similar? We will prove them similar by taking common as angle B. Here angle ACB is 90 degree and in the other part angle BAD is 90 degree. Therefore by angle similarity, both the triangles are similar. If the triangles are similar, their sides are in proportion. So we will consider only those sides in proportion which is required. Now students, second part is just similar to question number 2. As we have taken one angle as x, so here we will consider CAB as x. So when we compare the angles, we will get CBA is equal to CAD and CAB is equal to CDA. So again by angle similarity we can prove that the triangles are similar, and if the triangles are similar, their sides are in proportion. So we'll consider AC upon DC is equal to BC upon AC. When we do the cross multiplication, we will get the result as AC square is equal to BC into DC. Now the third part of the question number 3. So here we are going to consider the triangles DCA and DAB. Students, both the angles are equal to one another because both are of 90 degree. Next, CDA is equal to ADB because it is common between the two triangles. So the two triangles are similar by angle similarity. If the triangles are similar, their sides are in proportion. So we will consider the sides in proportion as DC over DA is equal to DA over DV. When do the cross multiplication, we will get the result as AD square is equal to DB into CD. Now students, question number 4. ABC is an isosceles triangle which is right angled at C. So that means AC is equal to BC. We have to prove that AB square is equal to twice of AC square. Students, I am giving this question as a homework to you. Do try this question.
So students, your today's homework is to do the third and fourth part of question number 1 as well as question number 4th of the exercise 6.5. Do revise what we have done in the class today and have a great day ahead, students. Thank you.